Solving trig equations. Most trigonometric equations have more than one solution. If the variable is not restricted, the periodic nature of the trigonometric function will result in an infinite number of solutions, right? So if we think about our sine function, which looks like this, if I ask you to solve for where sine equals, sine of theta equals 1/2, right, if I draw a line at y equals 1/2, that's going to have an infinite number of solutions. If the variable is restricted to two adjacent quadrants, a trigonometric equation will have fewer solutions. These are called principal values. For sine and tangent, the principal values are in quadrant 1 and 4. In quadrant 4, that's negative 90 to 0, not 270 to 360. So for sine x and tan x, x is from negative 90 to positive 90. For cosine, the principal values are in quadrants 1 and 2, from 0 to 180, and convert to radians as necessary. So solve sine x cosine x minus 1/2 cosine x for principal values of x. So both of these have a cosine in them. We can factor out a cosine and make this cosine x times sine x minus 1/2. Now we've got two things multiplied together to equal 0, so we can set each part equal to 0. So where does cosine x equal 0 on your unit circle? That's going to be at 90 degrees. And then add 1/2 to both sides. Sine x equals 1/2. Where does sine x equal 1/2? It equals 1/2 at 30 degrees and also at 150 degrees. But for principal values of x, we're only looking at the answers in quadrants 1 and 4, so that would just be the 30 degrees. 150 is not a principal value of x because principal value of x for sine because it's in quadrant 3 or quadrant 2. Solve cosine squared x minus cosine x plus 1 equals sine squared x. We are going to want to get all of these to be cosine because we got a cosine here and a cosine here. We want to turn this sine squared x into cosine squared x using the Pythagorean identity. So we're going to make this cosine squared x minus cosine x plus 1 equals 1 minus cosine squared x. And we can subtract 1 from both sides. That's going to actually make both of our 1's go away. We're going to add cosine squared x to both sides. So we get 2 cosine squared x minus cosine x equals 0. And again, we want to factor out the cosine x and make this 2 cosine x minus 1 and set each part equal to 0. So again, cosine x equals 0 or 2 cosine x minus 1 equals 0. Now our x is between 0 and 2 pi. So there are two places on the unit circle where the cosine is equal to 0, at pi over 2 and at 3 pi over 2. And then we add 1, 2 cosine x equals 1, cosine x equals 1/2. Where does the cosine equal 1/2? At pi over 3. And then also in quadrant 4 at 5 pi over 3. So here x equals pi over 3 and 5 pi over 3. So we get 4 solutions. solve secant squared x minus tangent to the 2 secant squared x minus tangent to the fourth x equals -1 for all real values of x. So again, we can't solve for a secant and a tangent. We can use the Pythagorean identity again and make secant squared x equal to tangent squared x plus 1. And so 2 tangent squared x plus 1 minus tangent to the fourth x equals -1. So this is 2 tangent squared x plus 2 minus tangent to the fourth x equals -1. And so rewrite this in standard form, plus 2 tangent squared x. We're going to add 1 to both sides to make this go away, and so this is plus 3 equals 0. I don't like to lead with a negative, so I'm just going to multiply this whole thing by -1 and switch all of the signs. Minus 2 tangent squared x minus 3 equals 0. This is factorable. We're going to factor this into tangent to the fourth x and tangent to the fourth, tangent squared x and tangent squared x. We're looking for two numbers that multiply to -3. It's going to be a -3 and a plus 1. Adds to -2. So tangent squared x plus 1 equals 0. Tangent squared, I can't write. Tangent squared x equals -1. Never going to be true, because something squared can't be a negative, right? You'd have to take the square root of both sides. You can't take the square root of -1. So that's not going to produce a real solution. But the other one, tangent squared x minus 3, means that tangent squared x equals 3, and we square root both sides. Tangent x equals plus or minus the square root of 3, right? The negative square root of 3 squared will also get you a tangent squared equal to 3. So where on the unit circle do we get a tangent of plus or minus the square root of 3? That's going to be where the sine equals the square root of 3 over 2, and the cosine equals 1/2. Square root of 3 over 2 over 1/2 is root 3. And so that ends up being pi over 3. We also have it at 2 pi over 3 is where we get the negative. We get a -1/2 and a positive root 3 over 2. And then also at 4 pi over 3 and 5 pi over 3. But this also says all real values of x. So what we want to do is we want to take all of these answers and add to find angles that are coterminal with this. So all of these answers plus multiples of 2 pi, where n is any integer. So all real values means that you have to add this plus 2 pi n, meaning all multiples, all coterminal angles, all angles that are coterminal with these angles. When you ride a Ferris wheel that has a diameter of 40 meters and turns at a rate of 1.5 revolutions per meter, the height above the ground in meters of your seat after t minutes can be modeled by the equation h equals 21 minus 20 cosine 3 pi t. How nice of them to give us that equation rather than making us figure it out. How long after the ride starts will your seat first be 31 meters above the ground? So the word first means we're looking for the principal value. the principal value will be the first time it happens. So h is your height above the ground. So set h equal to 31. 21 minus 20 cosine 3 pi t. And we want to solve for t. So we're going to minus 21 from both sides. 10 equals negative 20 cosine 3 pi t. Divide by negative 20. Negative 1/2 equals cosine 3 pi t. So we want to, right, 3 pi t is some angle. And so that angle, 3 pi t, is going to be the inverse cosine of negative 1/2. And so where does the cosine of negative 1/2, cosine first equal negative 1/2? That's at 2 pi over 3. So 3 pi t equals 2 pi over 3. We're going to divide by 3 pi. And so t equals, the pi's cancel out, and this is 2 over 9 minutes. Which, if you multiply by 60, is about 13.3 seconds. Solve. 2 sine theta plus 1 is greater than 0 for sine between 0 and 2 pi. So we solve this the same way. Subtract 1 from both sides. 2 sine theta is greater than negative 1. Divide by 2. Sine theta is greater than negative 1/2. So think about our graph of sine. Right? This would be one period of the sine curve from 0 to 2 pi. We want to find where it's greater than negative 1/2. So, right, it's going to be from here to here and from here to here. So these two sections of the curve. And so then all we need to do is figure out what these 2 points are. So that's going to be where the sine is equal to negative 1/2. And that is, according to our unit circle, the sine is equal to negative 1/2 at 7 pi over 6 and at 11 pi over 6. So all the places where it's greater than negative 1/2 are here, but because of our range, we need to say that we start at 0, so start at 0 and go all the way to 7 pi over 6. We're not including 7 pi over 6. It's an open circle here because this is strictly greater than. And then also from 11 pi over 6, not including 11 pi over 6 again, because that would be equal to. And then to 2 pi, not including 2 pi. So that would be our solution set.